students, in the last few videos we have discussed about basics of functions, types of functions and some special functions. In this video I will discuss about a topic, growth of function. Before coming to growth of functions, we should know that what is algorithm and how to evaluate the algorithm. First, algorithm. An algorithm is a finite set of precise instructions for performing a computation or to do a particular task. We write the algorithm for solving a problem. It can be described using any natural language like English language or using pseudocode. Suppose I give you a problem to solve, then you will write algorithm for that particular problem. Different students may write different algorithm for that problem. Then how we will evaluate that which algorithm is the better one. So most important criteria in evaluating the algorithm is the time it takes to complete that particular task. To do the meaningful comparison of the algorithms, we estimate the computation time. And that estimation of computation time must be independent of the programming language, compiler and the computer. It must reflect on the size of problem being solved, and it must not depend on specific instances of the problem being solved. The quantities which we often use for the estimation are the worst case execution time and the average execution time of the algorithm. Sometimes we also talk about the best case of the algorithm. And these all are represented by the number of key operations executed to perform the required computation. Let us take one example of algorithm. This is algorithm for sequential search. What we do in sequential search, we search for a particular item in the array. For example, we have an array of size 5 and the items are 11, 16, 1, 4, 9, and we want to search for 1. We will start with this index, that is first index, compare 1 with 11, values are not equal. Then we will go to next value, that is 16, compare 1 with 16, values are not equal. Then we will go to next index, that is this value, and 1 is equal to 1. So we will say that 1 is present at index equal to 3. Now suppose we are searching for an value which is not present in the array, suppose 13. We will compare 11 with 13, not equal, then 16 with 13, not equal, then 1 with 13, not equal, then 4 with 13, not equal, then 9 with 13, not equal, and value of index will become 6. It means item is not present in the array. So this is the algorithm which is searching for item X in an array of size n. Here indexing is from 1 to n and L is the array. So it will output the index of the element if the element is present in the array. Otherwise, if the element is not present in the array, it will output 0. So this is algorithm. Starting from first index, that is index is equal to 1, we have taken a while loop and compare the value of index with the size of array, and second condition is comparing the key which we want to search with the value at different indexes. And in this statement we are incrementing the index value if item is not present. So this will be the condition when complete array is traversed and the item is not present, and the output will be 0. So this is the algorithm for sequential search in the array. Now the worst case of this algorithm can be estimated using some key operation. Which is key operation in this array? That is the condition in the while loop. So largest comparison occurs when X is not in array or when X is at the last position. It means while loop is executed n number of times. So this n is used as an estimate of the worst case time of this sequential search algorithm. So worst case time of this algorithm is n, is dependent on n. Now talking about the asymptotic efficiency, when we look at the input size large enough to make only the order of growth of the running time relevant, we are talking about the asymptotic efficiency of the algorithm. However, the running time of an algorithm increases with the size of input in the limit. The algorithm that is asymptotically more efficient will be the best choice of our. Next, asymptotic notation. The notation used to describe the asymptotic running time of algorithm is defined in terms of functions whose domains are the set of natural numbers. This notation refers to how the problem scales as the problem gets larger. In some cases, it is important to look at how fast the problem is for small amounts of inputs, particularly when the same task is being done over and over again. But our main focus is with the algorithms for the large problems. That is how the performance scales as the problem size approaches infinity. Different asymptotic notations are big O notation, second big omega notation, and third is big theta notation, which we will discuss in the next video. Thank you.